All right, let's get started. So welcome to one of our workshops today. It's going to be called Serverless Data Processing Workflows in Jupyter Notebooks. And this will be on Pegasus's workflow management system specifically. And we will be covering on how to run a workflow, how to compile a workflow, and how to run it executably on any kind of allocation that you have. This workshop was inspired by Matt Syringe and Karan Vahi over at the University of Southern California at the Information Sciences Institute and supported by the National Science Foundation. So just a quick run through about me. If you haven't been here for our morning workshops, I'm Robin. I'm currently working on my undergraduate degree at the University of Michigan in Ann Arbor. I interned at the as a machine learning researcher at the Stanford Linear Accelerator Center in Menlo Park, California. I did that for 2 summers, and then I was a attendee sponsored by Access for Supercomputing 23 and Supercomputing 24. And I bring up Access because we use a lot of Access's resources, and they provide a lot of good tools to get us started, even with today's workshop. So we're going to be covering 4 main topics today. First, we're going to be covering about scientific workflows. Then we'll do an introduction to Pegasus specifically, Pegasus and their workflow management system, and exactly what makes them stand out in front of other possible workflow management systems. Then we'll go on to some hands-on examples. And then if time allows, we will cover some advanced topics. So a scientific workflow is an abstraction at its core. You have to visualize it as a directed acyclic graph. You have nodes and you have edges in a graph. And these nodes, every node represents a job or a task that you want to run. And then the edges represent dependencies. And what I mean by that is it'll tell you which job maps to which next job. It provides a layout for jobs to execute sequentially when required or parallelly when required. It also shows you that the outputs of one job are usually going to be the inputs of the next job. And the final thing is there are no loops or edges. Because it is directed and acyclic, you are not allowed to have for loops, and you're not allowed to have any conditional branching. This concept where you have these nodes and edges and the outputs being used as the inputs is a concept known as chaining. And that's what really runs Pegasus at its core as a workflow management system and allows stuff to be executed sequentially and parallelly when required. And that also requires for robustness within the program. So there's five main features of scientific workflows that I want to touch on. First of all is modularity. It's the ability for a job to run when required. That's pretty straightforward, right? If you have a job, you just want it to execute it into completion. Automation. This means that we don't want any manual intervention as we're running our job. When we have a workflow, we want to just let it run once and then not have to worry about it until the end and see the end result. Now, automation is pretty big in this because that also means we need some pretty good fault tolerance should there be any errors in the middle of the program or execution. Reproducibility. This means that whenever you run a job or a workflow with one type of input, you should be able to get the same output every time you run it with the same input. Meaning that I run the job with a specific input, I run it again, it should be the same output every time. Scalability. This means that I can run this workflow on my MacBook, on anything that is defined as a computer, anything that is a Turing machine should be able to run a scientific workflow. That means a Nintendo DS, MacBook Air, or El Capitan, which is the world's most powerful supercomputer. Anything should be able to run a scientific workflow. Finally, the last one is data provenance. That means that we should be able to tell where our data is coming from. We need to know the origins of our data. And that means we'll see later on how Pegasus implements all 5 of these features in order to provide a system that can effectively become a workflow management system. So let's talk about Pegasus now because we covered what scientific workflows are. So Pegasus originated as a, like I said, a workflow management system. It's funded by Access, and it originated somewhere in the USA. These two computer scientists, if we zoom into the western half of the United States and zoom into California and zoom into the Los Angeles area in Orange County, you'll find a little school called the University of Southern California. And it's by Mats Ringe and Karan Vahi, and this is one of their flagship achievements as computer scientists is they made this Pegasus workflow management system. So here are the components of the Pegasus WMS. WMS being workflow management system. So there's a planner and a monitoring and provenance logger. Okay, so that planner basically allows you to give it a file and say, hey, this is how I want my workflow to execute it. I want it to do it in this order. As we saw, Pegasus or workflows are managed as directed acyclic graphs, and that's exactly how Pegasus will interpret your jobs. So that means that we use something called HT Condor. And HT Condor because HTC stands for high throughput computing, and Pegasus is designed to run on high throughput computing resources, not necessarily high performance computing resources. The difference is high throughput computing usually deals with jobs that require many, many weeks, many months to run, whereas high performance computing usually deals with jobs that are, it'll take a couple of minutes, but they're embarrassingly parallel, and you want it to run quickly and not over a long period of time. So, but it can also work for HPC use cases, just to clarify. So HT Condor will have an engine and a scheduler, and what this does is this basically puts your job on the job queue, all of the jobs on the job queue, and then it's a job scheduler, right? And it job schedules using something called the DAGman, and that's what that will do. Now, in practice, I want to talk about the Southern California Earthquake Center, the second bullet right here, as an example of how Pegasus is used in the real world. So what happens is the Southern California Earthquake Center, they gotta model a lot of earthquake activity in the area, and Pegasus allows them to break these really complex, many moving parts into a smooth workflow. And some jobs you can run in parallel, and some jobs will depend on an input or an output from another job. So it'll let you structure that in a sequential order. Okay, the next thing is like I mentioned, key concepts. So Pegasus Planner, the DAGman workflow engine, and the HT Condor scheduler, right? So the DAGman manages dependencies and reliability. So it's the directed graph that I was talking about, just being able to execute jobs in a sequential order. And then we feed that into HT Condor, which is the actual job scheduler. It says, okay, this has priority. We're going to schedule this job first, and then we're going to continue. Like I said, workflows are directed acyclic graphs, no loops, no conditional branching. Planning occurs ahead of execution. This is really important because that means our planner acts like a compiler, not an interpreter. If you're not a computer scientist, what this exactly means is a compiler likes to look at all your code, check for any errors, and then execute at runtime. An interpreter goes line by line by line in program, and as soon as you hit an error, it'll throw, and then you'll exit the program. This is important because this guarantees more of a robust environment that you can work with. So we're going to scan the entire workflow first before we can run into any particular errors. Now, the hard part about this is, from an implementation standpoint, this requires very robust fault tolerance so that we can genuinely trace the source of a problem if one were to arise. Pegasus provides APIs to generate the abstract workflow. So let's say I wanted to run a job. I wanted to say, hey, I have these 5 jobs. I want to run them in this order. And I write them down on my iPad. I write them down on a piece of paper. That's this first picture on the left. Is we're planning stuff out in our head. What you can actually do is you don't have to know how to use YAML files. You don't have to know the formatting that goes into it, because Pegasus provides a Python API to do all of this. Now, the beauty of that is that it almost guarantees more of a accessibility, from an accessibility standpoint, a more accessible product, so that anybody can basically use it without knowing how to utilize their specific syntax or YAML structure. So it'll take this Python API, it'll compile it, it'll schedule the jobs, and then convert it into this YAML file. So we're not doing regular Python interpretation with this kind of stuff. Now let's revisit how this ties into our 5 features that we talked about before. First, we have the modularity. So modularity is pretty straightforward. Jobs are run, and they get the job done. Automation. We have the job scheduler. That's what automates everything. You write the code. It truly is a write once, run anywhere system. And we'll talk about more about that when we talk about portability in just a few moments. But once you write the code, because of all the fault tolerance, it'll either exit and it'll give you exactly what logs that you need, or it'll just say, or it'll run to completion. You'll get the output that you expect. Reproducibility. How is Pegasus guaranteeing reproducibility? Essentially, because this code is compiled and we never change the workflow unless you change the implementation or the Python API, this is truly a machine that can take an input and output without any loss of generality or without any loss of accuracy, or not accuracy, but any loss of consistency between the running of jobs. Scalability. Like I mentioned, this is both for high performance compute systems, high throughput compute systems, and you don't even need any high performance computing resources. This Pegasus workflow system can run on your MacBook, and you will be able to run it completely fine. And it's not strictly to Mac, just to clarify. You can run it on a Windows, you can run it on a Linux, you can run it on a regular computer, and it'll still run fine. Number 5 is data provenance. So Pegasus provides the monitoring tool that I talked about before. It allows the user of Pegasus to monitor what is going on live, and not only that, it'll log all its actions so that you can trace it back if there's an error and see where the source of the error is. So that's how we guarantee data provenance. And the last one, portability. I wanted to talk about portability. This wasn't one of the features of our scientific workflows, but it's kind of like an add-on to Pegasus, is that it really is a write once, run anywhere kind of scenario where, because we're writing in Python, no matter if you have Python, you're running Pegasus on your laptop or your high-performance computing resource, you can just use the Python code that you were using, call their API, and then just rerun the same thing without any loss of reproducibility. So before we go into the hands-on examples, does anyone have any questions? All right, so let's start with the hands-on examples. Doing pretty good on time. Okay. So this morning we did the Access account setup. So you should all have this, but let's go through it together. If you don't have an Access account, make sure to make one. It's pretty straightforward. So go to this link. It's pegasus.access-ci.org. Okay, that's pegasus.access-ci.org. And you'll be routed to an on-demand interface, open on-demand interface. Now, this website is really cool because they already have the examples for you, and you don't have to set up anything except specify the number of hours that you want to run. You don't have to specify GPUs. You don't have to specify whether you want an SP GPU or a regular GPU. You don't have to specify what cluster you want to use. This does it for you. This is set up as an environment so that you can truly learn Pegasus at your own pace without any knowledge of hardware restrictions. So let's go through it together. Click Jupyter Notebook once you're in the page. Number of hours, 1 should be fine, but let's be safe. Let's just go with 2, and then launch it. And then it'll be queued. You can refresh, and we're running. So now we have 1 node, and we have 1 core. We only have 1 core because, like I said, Pegasus really can run on 1 core. You don't need multi-core processors. You don't need super high performance compute resources. So when that happens, press connect to Jupyter, and you'll see this Access Pegasus examples on the Jupyter interface. Click that, then click number 1 tutorial running a complete workflow, and then run the or open the Jupyter notebook associated with that. Okay, so before I get into actually running the notebook, let's talk about what we're going to be doing. So like I said, it's very portable. We don't have to worry about any low-level execution details. You have a stage-in job, you have some in-the-middle jobs, and then you have a stage-out job, and then that's how you feed in the input, you get an output out. So there's more information that Pegasus needs. We can't just rely on HT Condor and Dagman to do the entire thing with the monitoring tools. You also need 3 more catalogs, we call them, okay? You need a site catalog. This describes the sites where the workflow jobs are going to be executed. So just because we schedule the jobs doesn't mean we know where to execute each job. So we'll have a site catalog to specify that. We'll have a replica catalog so that we can describe all the input data saved on the external servers, and then a transformation catalog, which describes all of the executables used by the workflow. So now let's go through our workflow. Okay, so just read this over real quick, and run the notebook, and then we'll take about, let's say, 5 minutes. I will warn you, when you run the wait, it'll take up to 10. It can take up to 10 to 20 minutes just to run the entire workflow. But we can keep it open, and then we can move on to other examples. But just don't exit out. It'll take a while, but you can see the progress because, like I said, there is live monitoring available with Pegasus. So just run the notebook. Feel free to call me if you have any questions or need any clarification. Okay. So we'll be back at 1:55. It's pretty straightforward. We'll just run the notebook. Oh, this is just a file explorer. This is just a SQL file explorer, but you can do the same thing here anyway. Oh, I see. But you can't run the notebook from that interface. You have to go into the Jupyter notebook interface. Yeah. Yeah. So just read it. Let me know if you have any questions. Sure.
Robin.
Yeah.
Yes, question.
Of course, yeah.
It reminds me of the other orchestration tools out there. Like, what are the differences between like Pegasus workflow management and like other like say ML ops orchestration tools out there where you orchestrate different jobs?
Absolutely. So, which workflow do you want?
I'm not familiar with the others, but just looking for like a
Yeah, so a lot of workflow management systems offer, like what I mentioned, the 5 scientific workflows. Those need to be baselines. Pegasus in general is really cool because it's completely open source. It's provided completely by Access, and Access allows you to have an open source interface to interact with these tools to begin with. It offers monitoring tools. Now, monitoring isn't really standard across all these workflow management systems, but we have not only lifetime monitoring and we have like historical logging going on. That's really cool. And then the biggest thing is the Python API. They developed an entire API just for you to be able to interact with it without having to define structurally a YAML file, which would require a lot more knowledge about the specific syntax that goes behind it.
Because like I didn't use that tool before, but like have you heard of Prefect?
What is this?
Prefect. But like
is this the AI tool that uses? Yes. This
so
is.
I'm not sure how they compare, but I didn't use it. I just stumbled upon it. Frustrated.
Yeah, absolutely. Yeah, I can explain this actually. So this is an AI tool. This uses AI to make your workflows, and basically what it does is this is self-updating. So this is actually not compilable. What it does is this is dynamic. So as your data changes, it'll make changes to your workflow. Now, there's an advantage to that, is that you can use it with a lot more complex stuff that requires live data. Let's say you're getting data live fed from a different API and you need real-time data. This is perfect for that. If you want, this is also powered by artificial intelligence, so it's just going to be smarter and less work on the user. The problem is, it's not a huge problem, but the big problem is pricing. It's not open source at all. You get it is better.
Pricing.
It's definitely going to be. It's better to get what you pay for, But in my opinion, this Pegasus tool is sufficient for a lot of cases. Like it can, even the South California earthquake center uses Pegasus, to work close. This is sufficient, but this is definitely easier to use.
But as the ideology and philosophy, everything is pretty similar in some sense.
Exactly, they're both workflow management systems. This just uses AI to reimagine a workflow system.
So it's more like if you know how to use Pegasus, in the future, if we are dealing with like time series of live data coming in, then let's say if you want to use other tools, then you could like get up to speed more quickly because you know how to use Pegasus.
Exactly right. Do you know what's it called, Octoline?
Yeah.
Okay. Do you know what Salesforce is?
Yeah.
Okay. So I was going to use that as an example. So Octoline is an AI Salesforce. So a lot of users, they find Salesforce to be useful because Salesforce has been around forever. Right? They're able to transition to Octoline really quickly, and Octoline also provides AI solutions for what Salesforce is.
Yeah. Thank you.
Yeah, of course.
All right. Was everyone able to at least run the job and are waiting for results by any chance? Does anybody? Yeah. Has everyone been able to run? Yeah. Okay. Cool. So that's a good sign, meaning that you were able to just run your first workflow on Pegasus, meaning we really shouldn't be bumping into any other problems today. So let's go back to the slides, and then we'll do some other examples. So I want to go back to this slide. I want to show you some example workflows, and then we'll cover the next tutorial here. So let's see. Okay. So everyone that has access has additional workflow tutorials, and we'll do this later after APIs and catalogs tutorials. But I wanted to show this slide because there's a lot of use cases for Pegasus. So you see it being used in artificial intelligence, log segmentation, mask detection, orca-sound, LLMs, and RAG. You know, Benjamin over here taught about RAGs today. Workflows are you can use a workflow to develop really complex LLMs and RAGs. So that's definitely a use case. You can use it in astronomy. Montage is a great example of that. You can look that up. Basically, some software that they have. Bioinformatics as well. You can use it for AlphaFold, Rosetta, variant calling, all these cases. So you can really see this is a multidisciplinary tool, and you really don't have to be a tech expert to use it, which adds to its accessibility and portability features. And it just makes it a lot better and more user-friendly to use. And it allows you to break down really complex tasks into simpler ones and execute it without any loss of reproducibility. So we ran our first workflow. We talked about catalogs. So then we're going to do some API and catalog tutorials right now. So API, because we talked about the Pegasus API, and you were able to run your first workflow, but now you should be able to interact with the API, do some more fun stuff with it. So here is go into the tutorial-API folder, and just go through the API tutorial. Let me know if there's any questions. So the whole point of this this particular hands-on tutorial is we want to familiarize you guys with the workflow API, right? So this specific example case is, we were talking about LLM RAGs before, so this is an extension of that. We're going to be providing an LLM RAG example in order for you guys to be able to see what an actual workflow is like, because you'll see the example before wasn't actually a real job. It was just a bunch of 4 nodes pointing to one node. So this is going to show you really what a more realistic workflow may look like. Okay, so just run the Jupyter notebook, read over. The documentation is linked, and it's pretty straightforward, but if any questions arise, please feel free to consult me, and we'll reconvene in about 5 to 6 minutes at 2:05. Like I said, workflows do take a long time to execute, so you may be behooved to, if you want to see the output result, to just leave this browser tab open. As you run, they do take a while to execute. So yeah, we'll reconvene in about 5 to 10 minutes, maybe more like 5 to 6 minutes at around 2:05, 2:06. And we'll talk it through, and we will move on to other examples.
Everything works, right?
Change this.
Oh, wait, that's actually from XS.
It's from Access. It's addition.
Do you have a partition for Pegasus? I actually have no idea which period it is.
Interesting.
Wait, it's so that guy. At Denver. He was like, Matt's is good. No, he gave me a crash course on it in person.
Really?
Yeah, he was really nice. He's super chill, yeah. Yeah, no, this is cool. That's the whole point is it gives you live monitoring, which is on demand. Does it show? Go to access. Oh, we go to apps. Let's just show this. Let's just where's the where are the jobs? Wait, that's just each notebook has separate jobs. Like that's these jobs. These are yeah. So how do we see those? You kill the other ones. Oh, you have to go back to the notebook. I want to see that. Is everyone good? Has everyone been able to run the jobs? All good? When you create the workflow, you see how right now it's saying workbook and then it like runs all the jobs that you define it upstairs. Not upstairs. Yeah, you have to define within the plan if you want us to run jobs in parallel. So how do I do it? Yeah. There you go. I'll run graphics. Thank you. Reading documentation. Yeah.
All right. Okay, so if we're all good, then let's move right along. Does anybody have any questions? Okay, let's keep going then. All right, so we did a hands-on on our API. Then I want to give you guys another 5 minutes to work on the catalogs one next. So you may be behooved to keep your current notebook tab open and just open a new tab and run the new notebook. So here we're going to be seeing how site catalogs, transformation catalogs, and replica catalogs work. We're going to be seeing really how the portability happens in the grand scheme of things, because the portability is a really nice feature of Pegasus. So run through this example. It's pretty straightforward. It shows you how site catalogs and transformation catalogs work, replica catalogs, and we'll reconvene at about 2:14, 2:15, I think. We'll give you about 7 minutes to run this. And then we can run our examples, which are really fun. So yeah, work on that and let me know if you have any questions.
Agree with it. Yeah, what's up?
In the previous meeting, said I should get 6 notes originally as
That should be the output. I think 6 notes is the typo. You should get 5 notes. And you do have 5 notes. You have 1, 2, 3, 4, 5. That's definitely a typo. But this is exactly the output you should be getting. That's thank you for letting me know. I'm excited. Yeah. Yeah.
No, I'm just looking at the API solutions because the catalog part is just like functions.
Yeah.
Okay, so it's not just referring to.
Yeah, referring to the solution.
Yeah. So,
Do we get everything ready?
yeah,
It's finished. You get something cool?
Yeah.
It tells you exactly what the outputs are. It's good. We get everything ready?
Okay, wait, my mic is on. A second.
Run it, fine. Go into solutions.
Okay, I did forget to mention the catalogs tutorial. It's just the functions themselves. In the same folder, there's a solutions IPYMB that you should be able to run, and you'll be able to get all the outputs that you need.
Huh. API. There's an API. It's just the solutions. Catalog should show you how to find them. Yeah. Right. This one should, right?
All right, let's see.
can we access the slides if they are available to us?
One more time.
Are these slides available to us?
They will be available right after the workshop. We're going to release the recordings and the slides. Absolutely.
Okay, so before we move on, does anyone have any questions? No? Okay, so let's move on to our next topic, and this is our topic about fault tolerance within Pegasus and how to implement that. We have this really, really cool function in Pegasus that the Pegasus API provides. It's called .analyze. You define your workflow as normal, and then we use .analyze on the workflow after you define everything, and everything runs, and it'll just take the entirety of the workflow for you, and it'll check for any errors, and when it does go into an error, when it does find an error, it'll output exactly what the error is, and you'll be able to resolve it within your code based on the feedback that you get. So you can revise your implementation. That's the beautiful part about working with Python, is that it's just your standard debugging process. You know, you get an output, you get an error. You don't now the thing is Python is normally an interpreted language. It goes line by line and executes line by line. But because we now are using Pegasus, we can check the entire workflow first, check if the true root of the problem, and then diagnose it as necessary. So fault tolerance. So with Pegasus, there's 4 really cool things that that's able to mitigate fault tolerance. And Pegasus, the first one, offers PostScript, okay? So in coding, we call an error output a non-zero output. When your code executes as planned, you get an output of 0 by default. Now, that's what we'll call it. It's more relevant in a lower level language like C++ than Python, where in C++, when you run a main function, you'll actually output or return the value 0 upon successful completion. You don't explicitly do that in Python, but it's implicitly implied that you will output 0 even if it's a void function. You won't output 0 per se, but it'll exit with a 0 code when it successfully executes. So PostScript, it'll detect any non-zero exit codes, and it'll parse for success or failure messages exceeding timeout. So that means if I'm running a program and I'm stuck in this really, really, really long loop. Now, I'm not saying a loop from one node to another, because remember we said these are directed acyclic graphs, so there would be a cycle if we had a for loop. I'm saying within a job, if there was a really, really long infinite for loop, then it'll recognize that, it'll time it out, and then upon timeout, it'll throw its own non-zero exit code, and it'll be able to say, job timed out at this node. Maybe you should check this out. Or if we do not get an expected alpha, maybe you were expecting an integer, but you outputted a string, then that's definitely a problem, and it'll diagnose that for you. So that's what PostScript does. Next, we have job retry. So basically, let's say a job doesn't run the first time. Now, usually that means if it doesn't run the first time, it's probably not going to run the second or third time because of its reproducibility feature. But it still does it, because sometimes there are little tiny differences in code. Like, for example, a good example of this is when we do anything with doubles versus integers. And the reason I mentioned this example is this happens all the time, especially, it doesn't happen as much in Python for sure, but when you're coding in a language like C++, what'll happen is you'll do like some comparison. You'll represent something that's supposed to be an integer as a double, let's say, or a float, if you know what a float is. And then because floating point precision isn't actually an infinite number of decimal places, and it's actually more of a limited amount, it may we may overflow it, and what you're supposed to do is in a lower level language and that's compiled, you would compare it to like a small threshold, an epsilon we call it, instead of actually comparing the two doubles together. That's a pretty reasonable use case where a job retry might, rerun it, and the floating precision maybe the second time around may be a little bit more accurate than the first, but it does do the job retry. And there's only a few cases where a job retry would diagnose a problem as well. So you can kind of narrow down the problem that way. We have checkpoint files. So jobs generate checkpoint file staging. Staging of checkpoint files is automatic on restarts. Okay, so this means we run the job. We say, this is how we're able to locate the problem. We're saying, okay, we have this checkpoint. It ran up to here, doesn't run anymore. We have rescue DAGs. This is really cool. So let's see what happens. Okay, we have rescue DAGs. Okay, so workflow can be restarted from the checkpoint file, recover from failures with minimal loss. So this ties into the checkpoint files. We have a checkpoint file. This is the last time we were able to run the job to completion, not to completion, but to a success point without exiting with a non-exit zero output code. We have this rescue directed acyclic graph, which can complete the job and then output because it's robust. What's going to happen when it throws an error? It's not going to try the rest of the code. Maybe there's some mitigation in the rest of the code that's not being used in the beginning, right? So there are rescue DAGs, so it can run the entire code and then output the error for you, because it would never get to the error outputting standpoint if there's an error thrown, if that makes sense. So we need to run the entire thing first, get the error output that's necessary, and then output the error. There will be minimal loss because it'll finish executing, and that's what rescue DAGs do. It's a cool concept. They basically prevent any misunderstandings that may be more common by rescuing your program in the middle of it. So that's fault tolerance, and again adds to the automation of our program. So there's very minimal manual intervention with Pegasus. You're not going in, you're not throwing exceptions. You're getting all this information because of a very, very reliable logging system and feedback loop. Okay. So Pegasus also comes with some command line tools. So you can use something called Pegasus Statistics or Pegasus Status. It'll show you the status of running jobs. You can use Pegasus Statistics. It'll show you the number of failed jobs, number of successful jobs within a workflow. And then a Pegasus Analyzer, same deal. It'll show you statistics. So there's these cool data provenance tools that can be used, and you can use it for debugging or seeing where the data came from. Again, data provenance and fault tolerance. So with that being said, there is a fourth tutorial. So if you go into the Jupyter Notebook, it's called Debugging Statistics. You can open this IPYNB. It'll use the analyze function that I talked about, and it'll be able to show you what the error is, and then it'll show you how to mitigate that error, and then you'll be able to debug your own workflow. Say you have an error, and you can actually get exposed to what an error message might look like from this tutorial. So this will be a pretty good tutorial. I think it's very insightful on how Pegasus works and really showing you exactly what the error debugging process looks like. Okay, so run this. We'll take it to it's 2:23 right now. Let's go until 2:30. And then we'll have enough time to cover our last tutorial, our last portion, and maybe one or two advanced topics, okay? And then that'll bring us right to 3 o'clock. And you'll be done. And as always, please do let me know if you have any questions.
train a machine learning model. And then if I don't specify, let's say my code, then I save a checkpoint. Not like Pegasus, for example, like PyTorch.
In PyTorch you're making your own checkpoint.
Yeah, let's say in PyTorch I didn't say I'm going to make a checkpoint, and then I put the training script as a one of the workflow object. And I run in Pegasus. Should I crash somewhere? Pegasus is a checkpoint.
Pegasus will generate its own checkpoint files. But now within the PyTorch shop, it's going to say this is the last. It creates checkpoint files based on nodes. So it'll say the node P4 when you ran to PyTorch will be the last node that ran successfully before you got to PyTorch.
So it will go back.
Yeah. But that's why we have rescue DAGs. It'll skip the PyTorch part and then execute the rest, and then it'll be able to help with something and say, hey, node, this PyTorch node never executed.
So let's say if I don't want to waste compute time when I train like whatever hardware and device, so I would ideally split it into part of the workflow is like checkpointing. So the checkpointing reduces successfully as a node that executes successfully.
Exactly. So
And then-
it'll behoove you to split these jobs into multiple nodes.
So then in an ideal scenario, then you execute training, whatever, and then whenever it saves the checkpoint, it reduces that successfully save the checkpoint. And then if I continue running the training for whatever reason down the road it crashes, then Pegasus will say we will see that okay, it saved some node previously at this point. It registered the checkpoint and it successfully executed every memory. I can restore from that point.
Exactly. So checkpoint file says, okay, this is the last point that executed. Rescue DAG comes in, rescue DAG executes the rest. That's good?
Yeah.
Everything makes sense though, right?
Yeah.
Okay, sounds good.
And also, is this how? I mean, I'm sure people don't exactly do this for AI agents, but similar that you do schedule workflows from it. So,
Yes, absolutely. But we're introducing Pegasus as a management system because usually, you schedule jobs on your own manually, but Pegasus allows you to do that automatically. And it has some real world use cases. So
thanks.
yeah, of course.
Alrighty, okay, so one more minute, we'll get restarted with the rest of the topics. Okay, so it's 2:30 now. Let's get restarted with the rest of the slides. So we're going to talk about some compute jobs. So the first thing is there's 4 that we want to talk about today. There's going to be test pool, cloud, HT Condor Annex, and OS pool. Okay, so the first one, test pool. So test pool, it helps users with an Access account but no allocation try the capability of compute jobs. So it's a small resource that's always available, and it can be used for development, debugging, and running small workflows, right? So you don't need an Access account, or you don't need you don't need an allocation, but if you want to run something small so you can try out test pool, this is, or try out DAGs and stuff like that, this is definitely a good tool for that. Cloud, on Jetstream, there's a custom image where you can, make it available to all your jobs. You can use these cloud resources. And then there's HT Condor Annex, enables you to provision compute resources on HPC clusters Some examples of that are San Diego's Expanse, Supercomputing Center's Expanse, or Purdue's Anvil supercomputer, enables you to use basically, we talked about how these compute resources are usually, or this Pegasus workflow management system is usually used on high throughput computing software, but it allows you to test it on high performance computing devices. The last one is OS Pool, so OSG, Open Science Pool. It runs jobs in distributed systems, okay? There's some special rules, special restrictions, capabilities, but it's basically a way to run your workflow on distributed systems. Okay, so we did that. So there is one last tutorial in the Jupyter. So if you go to the folder 5, it'll be called provisioning, and it'll talk about what we just talked about with these 4 compute resources. So just you can run this, and there's some text about it. You can go through it real quick. Take about maybe maximum 5 minutes. 2:38 we'll restart and go into some advanced topics. So at 2:38 we'll reconvene. You can read up about it. There's some documentation, and yep. So take about 5 minutes, and then we'll go into our last thing, which is advanced topics. Okay. Anyone have any questions by any chance? All right, sounds good. See you at 2:38.
I would think materials lab. I know how to do stuff.
Oh yeah, I will hit those. Yeah, I guess.
Yes.
So we're like a Harvard, it's on the first floor of the. You can have it storage small actually. Yeah, it's on the first floor of the. There's
Oh, okay, that's cool.
yeah. Yeah, they're mostly just a lot of people from even the ECU department, which a lot of people that do chemistry, it's in there. Like if they do their own chemistry, like a lot of it. So just like most of the people in chemistry are the same. Just they run it every chemistry, unless it's like shared facility, like students.
Yeah.
That's the first.
So yeah, that's kind of all of that there. And then I guess there's more like chemistry as well, kind of distributed throughout campus.
Okay.
Yeah, send me the email. This should be available. God knows how long after the workshop. So
Okay.
yeah, it'll be good, right?
Yeah, yeah.
The other workshop.
Yeah.
Oh, okay, gotcha.
You able to run everything?
Yeah.
Awesome. So you're walking in the back, you're ready to set up or everything, or?
I was just at the other. I don't really know everything about it.
Yeah, I saw that. It's really straightforward. Just go to Pegasus. It's like in the URL thing, just write Pegasus. Oh, like
What do I
in
got?
sorry, in the URL box. Dot. Oh, Pegasus dot access dash CI. That'll work. Yeah. Okay, there you go. So now we're on an open on demand interface. Just press Jupyter. And then 1 hour is fine, just launch it. And then all the workbooks are in the Jupyter file system that's run on Pegasus. So just refresh it once. There you go. Okay, so connect. Okay, and then go to the first folder. Yeah. And then we're on 5 right now, but you can do whatever tutorial you want.
Then that'll be fine. And then you can run everything in the notebook.
Okay, thank you.
Yeah. All right. All right. Oh, Mike. All right. Let's get started. So hopefully you found all the tutorials to be pretty straightforward. There will be, I don't know if you saw in the file system, there's another, I think, 3 or 4 tutorials on an artificial intelligence example. There's a bioinformatics example, and there's 3 more examples, I believe. You'll be able to, on your own time after the workshop, be able to access all of these tutorials still and be able to run through all the notebooks, no problem. You just have to start a new job. And you'll be able to use it even after the workshop and run through the tutorials. And those tutorials are more realistic. You know, they're more like using real world examples. You have an artificial intelligence example, like I said, and bioinformatics and so on. So you'll be able to see how these workflows are really relevant in the grand scheme of things to other disciplines. So the last thing I wanted to cover is, first I wanted to show you guys the support or the contact information for if you want to use Pegasus in, let's say, your research or any kind of workflow that you're making and you run into issues, there is a Pegasus Slack support network. And the beautiful thing about Access is that Access tends to have a pretty strong support network completely free of charge to use. So you can go to the user's Slack and mailing list on this link, and they have also email support. So we'll make these slides available after the workshop as well, but you'll be able to contact someone if you run into any issues afterwards, okay? So that's that. Now some additional topics. So I'm gonna skip that. Let's talk about Pegasus transfers. So you wanna transfer tools, you wanna transfer data within Pegasus, within a workflow or within workflows, and then you wanna basically, let's say, use different transportation or messaging protocols. So whether that be HTTP, SCP, online, Globus, Google, or Amazon S3. So Pegasus Transfer is a tool that allows you to transfer data internally. Automatic retries, parallel transfers, all the good features that are necessary. There's also credential management, so that's also really useful. So Pegasus can also use containers if wanted. So users can refer to a container they want to use, and you'll be able to use an image and be able to have workflows running. In the future, it looks like as of 2025, when these slides were, I actually met with the the creators of Pegasus actually about 2 days ago in Denver. But I think as of 2 days ago when they made this, they wanted to, in the future, maybe implement a way to specify an image build file so that you can just have this build file and run jobs. So that's cool. And they would build the Docker image as separate jobs in the executable workflow, export it as a tar, and ship them around. So by having this tarball, what you can do is you can make it a lot more accessible. So now you even skip that step of, oh, I have to open this allocation resource, I got to have the API. You can just give them a tarball with all the executables, run the jobs, and be done. That would be actually really cool, and you wouldn't even need computer science knowledge to really execute that. You would just need to know how tarballs work. So that's pretty exciting. So it's, as you can see, this tool is a constant work in progress, and there's a lot of future that can be used for that. So that's that. Let's talk about, I think, we have enough time for. Okay, let's talk about metadata. So Pegasus, they can associate arbitrary key value pairs with workflows, jobs, and files, right? Output files get tagged with metadata on registration, and at static and runtime metadata changes. We're doing a compile system, right? So compile, there's a compile time and there's a run time, right? So at compile time, we have this. We have application parameters in the metadata, and at runtime, we have performance metrics. By having this metadata, we're able to develop the logs as necessary. Okay, so I think this is pretty straightforward. Again, the slides will be available if you want to learn more about these extra topics. I did want to mention one last thing about NAIR Pilot. This stands for the National Artificial Intelligence Research Resource Pilot. So this is actually a really cool resource. It's created by the National Science Foundation so that researchers can interact with AI resources more easily and more efficiently. It's kind of like Access, it's an extension of Access's mission. You can basically submit proposals for research compute allocations. Let's say I want to use Access's allocations for this supercomputer. It's not even like a regular formal research proposal that's like 5-7 pages long. This is more of like a 1 to 2 page, quick proposal. It supports projects completely free of cost. And just to clarify, when we say free of cost, someone's paying for it, and that would be the NAIR Pilot organization is paying for these resources for you, meaning that you as the researcher don't need to spend extra money on compute resources, which can get pricey, honestly, especially if you use a really good supercomputer. But over at Access, they have really good supercomputers to begin with, many which are top 500 supercomputers. So that's really cool. And they even run events for students and for people upcoming, much bigger than this workshop. I was actually at one that I want to highlight. So this AI Unlocked workshop, this was a great opportunity. I'm going to be honest, fairly competitive. So they had, I believe, don't quote me on the exact numbers, but somewhere around 753 applicants. And they had about 200 attendees, I believe. So there was a 500-person wait list about. But that's not, I mean, the odds aren't too bad, right? Two out of what, 7? That's not terrible, I feel. But, it's worth a shot. And it was a really good workshop. It was fully supported in terms of travel, meaning they paid for your flight, they paid for all the food that you ate at Denver, and they rented out hotels for you completely free of charge. And there was a lot of cool companies there, like Amazon, AWS was there, there was Cerebras was there, some other companies were there, like Samba Nova was there. So it's a really cool workshop, and they, for 2 days, just talked about AI and introduction to PyTorch, TensorFlow. There was actually a Pegasus workshop there as well. So this is a really cool resource that I want to recommend to everyone. This NAIR Pilot thing. This was actually their first workshop ever that they did through NAIR Pilot, and it's supposed to be a 2-year program, hence the name Pilot. They want to see how the pilot goes, and if the pilot is successful, which it seems like it has been so far, they're going to make it into just NAIR. No more pilot, and it can be a more long-term resource that people can use. Does anyone have any questions? Okay, so that about wraps it up. Please feel free to come up to me if you have any concerns, feedback. I appreciate any feedback, constructive and positive, so I can better the workshop next time. Let's see. And other than that, we are all done. I think that was the last workshop, right? Are we doing closing remarks or?
Dr. Bletch will come and give you guys a tour of the data center if you want to see that.
Ooh, okay. So yeah. So we are getting a tour of the Duke data center. I forgot about that. So if you want to go on that tour, Sanjeev will give you more directions on that. But other than that, that concludes this workshop. And thank you so much for attending. And hope to see you guys at a future Duke IEEE event. Tomorrow. We do have tomorrow. I did forget about that. There are workshops tomorrow. And not only that, I hope to see you regardless at a future Duke IEEE event. All right, thanks.